So hello everyone, and the 8 participants are less, so we wait for 5 more minutes and we start in after 5-10 minutes. After 5 minutes we will start. So let's start. Good afternoon to everyone, and
good afternoon, sir.
Good afternoon. So I think so. Day for yesterday in the last talk, some of you are presenting that, and that day we have discussed about smart campus and machine learning, how we can use the ML for making the smart campus or smart environment, like this one. So now we continue in this the same direction, but in a different fashion. So in this today's talk, we try to cover two keywords. One is the edge device, other one is the supercomputers. So anyone heard about supercomputer before that? Before this talk, or have any experience about the supercomputer? Okay, so that means that we can solve the machine learning problem or whatever these problems are there. Different devices are there. So that is the, of course, the one way is that your computer where you can run the program. Whatever the program is there, you can run on your machine. That is the one way. The another way is that you can use some lightweight processing devices such as edge devices. So if you are using your smartphone, that is the edge device, so you can use that one device. So that is the next level of solving the problem, or where we can solve the problem. You can use your smartphone, or you can use your edge device for solving the problem. So that is the second way how we can solve the problem, and or where we can solve the problem. So you can use your smartphone or some lightweight devices in that case. Now the third one and the last one is that suppose the problem is too complex and we cannot able to solve that problem on edge devices or in your system, then we need a supercomputer sort of things. Supercomputer is a bigger size machine, huge processing power is there. Theoretically, we can say unlimited power, whatever you are required, that is available there. And they also have a huge storage, so we are not worried about storage point of view. The delay from data fetch from storage to the processor and once again back to the storage is negligible. But in traditional systems, this delay is significant because of the connection cables and other things. But in the supercomputer case, we are not worried about swap in, swap out, because your internal memory itself is sufficient. What the memories are given with the processor, that is more than sufficient what you are required in that case. So that's where that means if your problem is so complex or not solvable on your system, then you need to move on the supercomputer in that case. So in this talk, we will try to understand that what is the difference, where we need to use, and which one is the better option, whether your edge device, computer, or the supercomputer. That is our agenda. And before I start this talk, I just want to run a small video clip. I need to check. Give me a moment. Yes. So IIT BHU has one supercomputer, and a supercomputing machine is there. And this is their virtual tour sort of thing, since because this course is online and I want to familiar with that one. So I just speed down, I don't know how to do, but yes, we can start. So of course there, so this is the location of the supercomputer, which is in nearby this academic building and inside the IIT BHU campus. And so this is don't think so readable, but yes, I just try to read it. So this is the specification of the supercomputer which is available at IIT BHU. So the capacity of this supercomputer for solving the machine learning problem for nature related problems is 837 teraflops. And it's huge capacity, we can say this, this they have the 10 memory nodes are there, and have 192 CPU nodes, and each node has the 192 GB memory, 192 GB internal memory. Think about that. We have 16 GB memory, 16 GB cache memory. Here each node they have the 192 GB. And high memory nodes, those they are the high memory node, they have the 768 GB capacity each node, and we have the 20 nodes of the high memory node. GPUs are there. There are 22 GPUs are there, which is V10 PC models are the GPUs. So total memory is 54 terabytes. Huge memory is there. Still that is available. That means free for future use like this one. So that means still there is no saturation. We can't say ki complete memory is over. No, that is still there. So this is the specification of the machine capacity. More specification, CPU is 192 nodes. 7680 cores are there, and this is each node is specification like the high memory node and GPU. So entire machine, they have the three type of the node. One is the GPU, other one is the CPU, third one is the high memory nodes. High memory node processing power is more or less that your CPU, but they have huge memory. So if your program required a huge data set in a temporary memory or huge data set or data at the same time, then we go to the high memory node. Example is that means physics department is there, or aerospace is there, some cancer research is there. So they need all the memories at the same time. They are not allowed to swap in, swap out. So say for example, A equals to B plus C. So B variable and C variable is required at the same time. So if then we can perform the operation plus. So the same thing is there. So if your simulator tools or if your program required the entire memory at the same time, a huge memory is required, then this type of nodes are very helpful. And if you require the huge processing power, then GPUs. If you are required the multiple low processing power nodes at the same time, then CPU. So this is the way the machine is there, and this is the first supercomputer in academic institute, the Param Sivai series. So this is the Param Sivai. So Government of India started the National Supercomputer Mission in 2017 onwards, and at that time they do all these installations and other things. So this series is known as the Param series. So Param Siddhi, Param Sivai, all these things are there. So in Varanasi we have the Param Sivai supercomputer, and this is their entry gate. This is the real machine. So this is a one supercomputer. So I think so that on the visual that somehow this is visual on your screen. So this is a entire system is there, and this is, we can say, one computer. So think about that, the size of the computer. This is the supercomputer. So numbers of processors, memory, or everything is working together for making of this. So this is the Param Sivai, the first supercomputer in this. So here these are the CPU, GPU nodes are there. Green color light blinking, LED blinking indicates that they are working. They are in active state and they are working for solving the problem. And this is their storage connections or whatever is there. So, and that is monitoring body. They monitor that, okay, if anyone is shut down or not, if any issue is there or not. So they indicate that yes, it's working because of the light. And this is for checking purpose. This machine is installed by the CDEC Pune. So say for example, here the red color light indicate they are not working and have some issues in that case. Either the node is shut down or have some problems in that case. So we need to observe that, okay, which node they have the problem and why they have the problem. But the green color indicate they are working properly, and this is some sort of the storage in the back side of the machine of a supercomputer, that their storage is there, and you can store the data. So Atos company, they have that time they have manufacture of all these processors and hardware part. Now numbers of companies are comes into the picture, or right now the Make in India, the computer nodes, supercomputer also available in India. So new machines are in Make in India. These are the previous machines they import from Switzerland. So their constraints are very high, that such as cooling and other things. Make in India machines are quite good as compared to that one. And this is their DDN storage is there. So DDN, they provide the storage of this one, and huge storage is there. In that case, UPS is also there for providing the power supply and other things. So this is the entire machine only. So back side of the machine, these are the cooling plant. So cooling pipes are there because of the heating purpose. So this is the indicator that the cooling is going perfectly. If the red color light indicate the cooling is not. So front side is the processor's memory and back side is the cooling system. So these are the chillers pipes are there, cooling purpose is there. This is the right now the empty rack in that. So we can also add incorporate some more CPU nodes on the memory node because the space is available as of now right now. So this is all about the supercomputer virtual tool sort of thing. So this is the cooling pipe, one is in, another one is out. So goes inside, do the cooling, and once again go outside. So with the help of this, the cooling system works perfectly. And since this is the first machine of supercomputer in academy, so that time the water cooling is there. So I hope so in your institute, maybe possible you have some machines. So different type of the cooling systems are there. Right now, new supercomputers of the new IITs recently IIT Patna also bought one supercomputer. So now whatever the new processors that are designed or manufactured in India, and they are using the gas cooling, not the water cooling. And so this is the water cooling machine. So cooling with the help of chiller waters and other things. These are the UPS for cooling plant, also for that machine running and other things. So this is the entire power system for this one, for this running the supercomputer continuously. So huge power consumption is there because of the process. These are the battery unit to provide the battery power supply of this machine. So if power goes down, so at least 20 to 25 minute battery backup is there, then DG set and other thing comes into the picture, so that there is no impact. And also if continuous power supply is also there, then still they are going via battery, not directly because of the fluctuation in the power and other things. So this is the entire battery room. This is the back side of this supercomputer machine, where the one big size of the DG set is there. So they provide the entire power supply to machine, to chiller, to all these things, because chiller consumes huge power. This is the electrical machine chiller. So this is the DG set. Once the light goes, then of course the supercomputer runs with the help of the batteries, and within fraction of the second DG automatically comes up, and these are the chiller plants. So they, since this is the water supply based machine cooling, so these are the water cylinders are there. They are the cool water is there. So cold water goes from the chiller to the machine and once again pumping. So this water supply continuously going here and there, and to control the corrosion or damage of the machine, or these pumps use some chemicals and other things also. So water changes in the waters are not frequently. We do all these exercises in an interval, so sort of things, not change the waters and other thing, because of they use some chemicals and other things inside the water to protect these chiller plants and other things. So this is all about the supercomputer. So the main machine, if we go to once again here, so you can see that the complete machine is this one. This is your supercomputer, and or because of this machine you need to do all these battery power, chiller and all these things to run this computer effectively without any interrupt and other things. So right now huge amount numbers of people, they are using this supercomputer inside and outside. So so my suggestion is that please go through the homepage of IIT BHU, then supercomputer section. So if you are interested, you can also fill the form and submit it, and you can utilize this machine also. So this is open for that means IIT BHU users as well as others users. So anyone can use, not only IIT BHU. Of course, some payment mechanism and other things are there for users and other things. So if your program is so complex, then definitely we need to move to the normal system, to the supercomputer. If your program complexity is less, but at the same time you are required a numbers of processor, controller and 100 GB, 150 GB at the same time, then also the supercomputer is only the option. So physics department, weather forecast, that all they use. Without a supercomputer, weather forecast is anyhow not possible, because when you predict or when you forecast the weather, huge satellite data is there. At the same time, you need to do all these processing or see the data or do all these exercises at the same time. So because of that reason, we need a machine. They have all the data at the same time, storage as well as the processing. So weather forecast and other things are that is good in the case of supercomputer. And but that means we can say this is the national supercomputer mission because of these machines comes in IIT systems and other things. And earlier we are in a very poor condition on the supercomputers as compared to other neighbors countries. So still we have very less supercomputer power. I think so. We have around 1% or 2% of the around the world supercomputers. And most of these countries, say for example, China and US, they have the 41-42% supercomputers. So we have very, very less supercomputer power still in the institutes and academy. Because of the both things, other one is the cost, other one is the maintenance is so high in these type of systems and solutions. So now we start our talk after this virtual tour. So this is a very interesting picture. So there are two processors are there. One is a small processor, your smartphone processor, we can say Arduino board, we can say, or Raspberry Pi like this one. These type of small processors are there. Other one is the supercomputer, very big processor is there. Why we call these two are the processor? Because of, say for example, here one small ant is there. That is also a processor, and elephant is also a processor. Processor, why? Because they can talk, they can see, they can listen, they can move, all these things, all properties are there. That means either you use the smartphone processor or the supercomputer. both are doing the processing, both they have the storage, both they have the input, output, everything they are doing at their own capacity, at their own level. But we can't compare the processing, but yes, of course, the functionality is there. So one small type of the small ant also, they can eat, they can listen, they can see, all these things as compared to the elephant, but capacity are different. So that means the edge device is also important, supercomputer is also important. Only we need to figure out which one is suitable. So in this right side is one small size of ESP32 CAM model. The cost is around 400 rupees only. Okay, this is also a processor. They also have an entire communication unit, storage. They also have a small size of the storage, and everything is there. The left side is one supercomputer, which cost is around 40 to 45 CR. And the entire cost is 40 CR plus. So think about that. This is machine is the 400, 500 rupees, and this is the 40 CR entire setup and everything. So a machine alone is around 18 CR. So think about that. The cost comparison, processing comparison, storage, and other things. So now we come to this focus on the supercomputer first. So supercomputer, the name indicate the machine, but the generic name is the high performance computing. So that someone find out in a burning or interesting keyword, they say that this is a bigger size computer, we can say a supercomputer. But logically, the supercomputer is a name, and high performance computing is a technique or a solution. So if you want high performance computing, supercomputer is there. But you can do also the high performance computing with the help of other solutions. And when we propose some algorithm, say for example, parallel processing algorithms and other things, that time we say this algorithm is for high performance computing. We can't say this algorithm is for supercomputer, because the parallel processing is also possible with the help of other type of processors, not only on the supercomputer. So that's why we say this is the high performance computing. So because of that reason, in academic, we have the subject or the syllabus for high performance computing subject, not the supercomputing subjects. Only because of these things, high performance is a logic, is a algorithm, is a techniques, or the solutions. Supercomputer is a machine name. And of course, they have one powerful computing system. System means they have the storage, they have the processing, everything is there in there, and suitable for the complex computational problems. As we already seen that discussed that various type of the complex problems such as weather forecast and medical science and other things, all they use the supercomputer because of the problems are quite complex, quite lengthy in that case. Now we come to this, why do we need the HPC or supercomputer? Because right now the supercomputer is there, earlier there is no supercomputer, so why high performance computing is required? So one is that solve the large and the complex problem. There are two keywords are there. One is the large problem, other one is the complex problem. So large problem we can solve on the normal computer. That means my laptop is also able to solve the 100 GB data set. They can process 100 GB data set, not to worry, but it takes 10 days. So that is a large problem. That means the computer, they can solve the large problem, but they require a huge time. Complex problem is the tricky problem. They need all the variables at the same time. They need a huge library support in other things. But the problem is not a large, but that is the complex problem. That means at the same time, they need hundred library supports. So both type of the problems, complex problem as well as the large problem, can address by the supercomputer of the high performance computing. And why? Because of the time constant is there. So say for example, if you have the 100 GB data set and you need to search one person face recognize. So 100 GB data set, numbers of images are there and you need to recognize the face. If they take 10 days to recognize in a normal computer, then definitely or maybe possible their application is not suitable for real-time systems and other things. 10 days is so long time for tracking a one person or finding whether this is face match or not. So in that case, the HPC is the better solution where you can quickly solve your problem. And every industry, they use this one right now. We can't say that they are using or not. When we put the problem on the Google Cloud and other things, what backend they are using. They use the supercomputer or they use the normal computer. That means definitely they use the supercomputer to solve the problem. And not only that, this real-time problem, they are also suitable for the simulators, and especially suitable for the simulators. So what real-time, we have a limited data, a problem is there. Say for example, face recognize. Real-time, you already have the trained model, trained machine learning model. You have only one face is there. You need to recognize that face. But when we training the models, at that time we have the huge data set. So simulator demands is high as compared to real-time solution. When you want to simulate one physics experiment or the weather forecast or disaster, that time you need a huge processing power because of the searching space is infinite. You need to solve the problem in a very complex, a very large searching space. So definitely you need a huge processing power, and a large space is required in that case. So this solution is suitable for and effectively suitable for the simulator environment, and not only this real world environment. Now, benefit of high performance computing is speed. One main benefit is the speed. Weather forecast, and a cyclone comes into the picture, so you can't wait 10 days for result. Whether cyclone is there or not, if there, what is the strength of the cyclone, what is the wind speed is during the cyclone. We can't wait for 10 or 20 days. We need to figure out in hours, in a fraction of days to solve this problem. Numbers of cases are there where the need to solve the problem in a very quickly, in a very effectively way, in a very short period of time. So medical science, they need a supercomputer because our body is one of the complex system. The numbers of things are working simultaneously, or if you want to work on the disease and other things, then definitely need to supercomputer. So cancer hospitals in India, they are using the supercomputer. Okay. Only because of numbers of things are working together and need a one space where simultaneously monitor all these things. Of course, not by the man-made effect, that is monitoring with the help of some simulator tools, but at the same time they need to monitor if something is happen here, and then what impact is on the other places. So that type of calculations are there. Mathematics and computer department also use the supercomputer for mathematical analysis and other things. Accuracy is the another reason for using the high performance computing. Because of HPC is there, then huge data set is there. You can process the data set very quickly, very effectively. So whenever you have the huge data set, whenever you have the huge processing power, then definitely accuracy automatically comes into the picture. So because why we are not using huge data set? Because of the constraint in the processing and other things. So your training takes 5 days. If you use the huge data set, it takes 15 days. So people are not able to wait, and therefore they reduce the data set size and select some important that means the important items as compared to all the items. But if you have the huge space, huge processing power, we can use a large data set. Why we are restrict ourselves on the limited data set in that case. Scalability is also there. That means your solution is scalable. You have this, that means scalability is there. You can add more GPU node or CPU node based on the web, because that is already interconnected. Only you need to write the script in such a way so that you can add more nodes in that case. That is only there. The scalable feature is there, scalability is there, and that is the scalable as whatever your demand is there, what is the problem demand is there. Cost effectiveness is also there. That is very important. People are say that okay, supercomputer is very costly, but per unit operation cost is very less as compared to normal. If you are effectively use the supercomputer, if you have the supercomputer, but your task is very limited, you are working for 500 element searching, nothing to be useful. Better you can use the normal computer, shut down the machine, supercomputer machine. But if your task is so complex, you need a huge processing power at the same time, then that is a cost-effective solution. Otherwise, what's happened that you can connect hundred machines simultaneously, or one server, or all their setup is there for solving this one problem. Still, the problem is not able to solve with a good accuracy. So then the challenge is there. So that's why people say that if you have one machine, of course the machine is costly, but it's still better than a small size of the machine. So that means cost-effective solution only the possible when you can utilize the machine fully. Very simple example: if we take transportation, you have one car is there, a small size of one bus is there. Bus cost is higher than the car cost. If we take a simple example, then but bus transport is suitable only when you have the sufficient passengers. If their empty seat is there, then definitely the bus cost is higher than the car cost. But if 40 passengers are going, then per passenger cost is very less as compared to car transportation. So that's where overall conclusion says that the HPC is suitable for the speed, accuracy, scalable, and also the cost effective. So if you want to purchase some cores or the processing power of supercomputer, say for example IIT BHU supercomputer, and per operational cost, or if you have purchased one CPU, GPU server in your institute, your cost is much more higher than whatever the cost you need to pay at IIT BHU for the supercomputer. So now up to this slide, anyone has any point or want to discuss or have any comment they want to know about the supercomputer or why we are using the supercomputer? Good. So we move on. So history of the HPC, high performance computing and supercomputer, how it comes into the picture. So very initially days or 1916 days time, that time mainframe computers are there. That is the beginning of we can say the computers, the supercomputers is just starting. 1967 mainframe and the supercomputer becomes more popular. That time people are so surprised that whether it is possible such type of bigger machine. So these are the pictures of 1960, 1970. So IBM was very active at that time. They proposed multiple computers, either small size, bigger size, and one. So first computer comes, supercomputer comes, name is the first supercomputer was known as because of their speed and the power. So people are quite surprised that they can solve this level of the problem in a within a time. And that time only one or two supercomputer in the entire world, not only in a one continent or the country. So in the entire world, if one or two machines are there, they can solve the problem at this speed and power. The people are quite surprised. Same as right now the quantum computing. The quantum computers are so costly, and people are surprised if you have the quantum computer right now. So that is that time the picture was there. But right now the supercomputer is almost every IIT or NIT or institute, they have their supercomputer. So in that case, we can say this supercomputer is not a big thing right now. And also that means every Indian state, they have one supercomputer, if we say that in a very normal language. Now, that means there are two types of the computing is there. One is the sequential, other one is the parallel computing. So this supercomputer is suitable for parallel computing, not the that means sequential computing. Why I'm saying that? If you have the sequential computing, then one after another is there. So in this picture, you can see the dots are the processors. So different colors of the dots are there. That means different processing power. Let me assume that. So, and if they work parallelly, then we have the fully utilization of the supercomputer. If we algorithmic, if we take an example of searching. So 1 lakh elements are there, to 10,000 elements searching here, 10,000 searching here, 10,000 searching here, like this one. That means we can divide the problem into the 10 sub-problems, and each node they compute 10,000 elements. So 110 times is required. And whenever we find that element, whenever a node find that element, okay, I got this element, whatever searching is there, then others element they switch off their searching space because of the element is already there. So such type of problems known as the parallel computing, where parallel searching is there, and whenever sequential searching is there, that means one after another searching, linear search is there, one we are searching. It takes time, but of course the one processor is required. Numbers of methods are also there. That is the part of the library of the supercomputer. They can automatically convert the sequential to parallel. Because supercomputer is effectively used when you have the parallel computing algorithms. Parallel computing, that means at the same time multiple nodes are working for solving the problem. And if your algorithm is a sequential, assume that one beginner is there, they have a machine learning problem, they enter the sequential logic. So the computer, whatever the supercomputer algorithms are there or libraries are there, they automatically convert this sequential into the parallel. And then after they execute, they automatically that means catch the processors, whatever the processors are free, and they run the program in a parallel fashion. And once the problem solved, they saw the result. So as a user experience point of view, you are not worried about that. I know the machine learning only sequential writing. I don't know about how to write the parallel programming or parallel computing algorithms. So that is the job of the supercomputer libraries or the framework. They automatically convert sequential to parallel. So assume that if we take A equals to B plus C and D equals to A plus C, so when A results come, then only the second equation execute. This is the sequential. In the parallel, what they will do, they take one addition in one place, another addition in another place, and result transfer whenever the result is there. So some portion of the problem, not the complete problem, but some portion of the problem we can solve in the parallel. And that is not possible in all the cases, but most of the cases, we can convert the sequential into the parallel. Graph theory, sorting, searching, or whatever problems are there. So another example, if we take that, say for example, you use the Make My Trip website for your ticket plan from A place to B place flight ticketing. So if sequentially they search one by one, okay, this place to that one is the connected, zero up count is there, flight is there, that means zero stop is there. If yes, then they show one by one. Another searching parallel computing, what they will do, they divide the searching space into two places. That means Varanasi to Delhi. They are not sequentially search one after another. They make a clusters, and within that cluster, if any option is there, they display that option. Within the other cluster, if any option is there, they also display their option. Why? Because of this is a direct zero stop connectivity. That means it is not possible A to B, B to C. So you are not required to switch from one cluster to the another cluster. Either cluster one, they have the A node and they also have the B node. Then only you can say yes, direct flight is there. So that means the techniques are there. They can convert sequential to the parallel algorithm. And the supercomputer is suitable for sequential to the parallel or parallel computing. Now, this is the picture of course, the supercomputer Paramsivai that we already seen that. And this is the HPC there. And special application or the main application of medical science or drug discovery, they use supercomputer IIT BHU in a large scale. So most of the users are there, and the processing power is very high. Storage capacity is very high of this supercomputer. Cloud computing and supercomputing are emerging topics right now, and what's happened that when we use the cloud computing, say for example, right now we are doing the Google Meet. So I am here, you are in other location. We are doing the Google Meet with each other, see the face, see the PPTs and audio. But we don't know about which computer the cloud use. So of course, this goes to the Google, because we use the Google Meet. So Google server is there, Google server, whatever the streaming is there, they take this input streaming, that is the output streaming, try to do the zero latency or zero delay. But of course, the Google, whatever they are doing, Google search, so Google server is there. So which platform, that means they use the normal computer, then you use the supercomputer, we have no idea. So indirectly we can say the cloud computing, they use the supercomputer, but user interference or user is not required to know each and everything. You use as a normal user supercomputer, but that is working for you same as the normal computer. You only see the results of that, okay, I got the result in a very soon. Why? Because of you are using a high performance machine at the server side. Another example is that, say for example, you want to make some caption in a video movie. So one video movie is there or video clip is there, or you want to write the captions in that. So normally image processing or multimedia system, that takes huge processing power. So if they use the supercomputer, they can solve this problem in a parallel fashion. So they are not required. They need to see that, okay, what's going on in a sequential fashion. They can solve this problem in a parallel manner. Now we come to the component of the HPC. What HPC components are there? That means, as we already seen when the virtual tour, there numbers of components are there, but here we can see the component. So normally that high performance computing, they have three major components. One is the compute node, which is used for processing the data. That is the compute node. They compute the data. The second one is the network node. Network node is used for connection in between this processor and processor, and also the connection from processor to the outside world. Connection from processor to your storage. And third one is the storage. So as you already seen that Param Sivai, they use the DDN storage. So DDN is one company name is there. So they use storage purpose. So processing node, they have a storage, but the main storage is in the DDN, and DDN use this storage for the purpose. Now we can compute node. So as we already seen that the compute node used for processing power. Here in the picture, the red color indicates some shutdown or default in that node. Green color is in perfectly working or active mode and using the processing. Yellow color indicate the ideal condition. That means the nodes are ready to use, but right now that is in ideal state because of no task is there, no job is there. So, and compute node is also the multiple types of the compute node. Some compute node they use for solving the problem. Some compute node is used for taking the input to the next compute node. But of course, they process all the compute node. They process some data, and these compute node, how they design, they are the cluster. That means they connected multiple compute node together for making the compute node. Say, for example, cluster is there, multiple nodes are there. If we merge all together, if we connect it with each other, then we make a one high-end compute node in that case. Now the second one is the networking. Why networks is required? Networks is required between the compute nodes within the HPC. So these type of cables are that means resistance free. It's very high cost cables, and they have no resistance. One processor or one storage to the another storage, another processor connectivity, they take the zero delay. Of course, the theoretically zero delay, but practically, of course, some delay is there. But assume that they have the zero delay because of that is the different type of the cables connections are there. Now, when we talk about the connectivity between node to node, between node to the storage, then numbers of topologies come into the picture. Topology means how these nodes are connected with each other. They are connected in a tree topology. That means one root node is there, one main node is there, their childs are there, their child also connected with sub-childs, like this type of tree is there. So such type of connection terminology or topology known as the tree topology in supercomputer. So here the thing is that the main node is the root node. All the nodes are connected via this node. So say for example, if this node want to communicate that one node, so they can communicate via the root node. So first data start from this node to the root node, and then after root node to that one node. So this type of mechanism is suitable only when every time you need a root node permission. Then it's good. And also this type of mechanism is scalable. You can add more childs, you have the more bigger size of the system, more bigger size of the network in that case. Now the second one is the ring topology sort of thing. All are connected in a ring fashion, but also make a mesh network. That means they are connected with each other also there. So they can directly communicate with each other. So such type of topology are quite fast as compared to tree topology, but in the tree topology, one controller body is there, and the controller body, they have the entire information of the topology. So in that case, the control is quite easy, and updation or changes are very easy as compared to the normal. But yes, please. अभिषेक शर्मा अपना माइक म्यूट करें प्लीज। अभिषेक अपना माइक म्यूट करें।
3 पर्ची आपके पास आई होगी। एक बस आई है और कुछ नहीं है। 3 पर्ची था, 3 पर्ची में हमने एक ही फाइल दे दिया है। 3 पर्ची को सब एक पर्ची में कर दूंगा। फिर एक पर्ची देखिए सर, विकास बोर्ड का सबका है सर, हमारा नहीं।
अपना माइक म्यूट करें।
हमारा नहीं और दो का देखो जिसका चला उसको मैं टिक भी कर दिया और सो भी कर दूंगा। हां सर, सो सर मैं 2 गेम में पार्टिसिपेट भी किया।
अभिषेक शर्मा
ये सही करने की जिम्मेदारी है ना, देख रहा हूं मैं तुरंत कर दूंगा।
अभिषेक
वहां सर उसके में हम कल ऐसा भी कल आएंगे ना, अपना नाम पर साइन करेंगे, ठीक है? नहीं मतलब
अभिषेक प्लीज माइक म्यूट करिए। अभिषेक माइक म्यूट अभिषेक
क्या बनेगा क्या?
जितने भी एक माइक म्यूट करवा अभिषेक के बस एडमिन में होगा वो, है ना, डिस्कनेक्ट उसको। So in that case we continue and here अभिषेक अपना माइक म्यूट करिए। So any other participant have any point meanwhile we can discuss till this talk? अभिषेक अपना माइक म्यूट करिए ताकि हम लोग स्टार्ट करें, आपका नॉइस बहुत ज्यादा है। हाँ ठीक है ना। So we continue our here after this topology. So here we can see that there the tree topology, star and mesh topology like this one. So whenever you want the more control, whenever you need a root node to monitor the entire system, then we can go in this fashion. This fashion is also helpful if you want to add some more nodes, but suppose directly one-to-one connection, then this one is the better option in supercomputers, so that the nodes are directly connected with each other. Third one is the hexagon 3-dimension shape, that is, you know, X, Y, Z, all these connections, some topologies are there. So this is the best one and have the good command on the systems because of all they are connected with each other in that case. So all these are we need to take care about the architectural design, not when you run the machine learning program. Whatever the topology is there, you are not worried about that. You have the program, you want to run your program, you can directly run your program without worried about that, how they are connected with each other and what is their connections and other things. So because we are not that means thinking about the connections and other things in that case. Some of others are also there. The hypercube is there. This is more than 3-dimensional or 3-dimensional and above, and HyperX is huge dimension is there. I add more and more dimensions in that case. Now we come to these type of cables and connections. So what type of the channels are there? So infrared is the channel or the fiber cable between the nodes for high speed communication. So if you have such type of the cables, then you are not worried about the resistance. You can transfer huge data set or the huge data in a very fast fashion or very effectively. That is the infrared. Ethernet is of course the slower than that one, and this is not up to that one. And integrated platform management interference is the third one, the hardware solution for control and managing your servers. So control your solutions and how they are connected with each other is the IPMI cables in that case. Storage, as we already seen that DDN storage is there, and storage connected with the processors in a very fast. So whenever you have the huge machine learning data set is there, you can store on these storage. And keep in mind that processor also they have their own storage, and this is the secondary or additional storage. So you want to swap in swap out is required in this case, and but luckily that the cable resistance is 0, delay is likely to be 0, so you are not worried about the swap in swap out or delay of the swap in swap out. So your solution is working very effectively or very fast fashion because of your delay is more or less 0 from device to that one to the device. So this is good for us that okay, our speed is not impacted because of the storage up and down. This is the complete architecture of this one. Of course, we already seen the main machine, but yes, if we are not see the main machine, then they are connected by like this one. So interconnected compute nodes are there. They are connected with each other that we already seen in the front machine is for this type of interconnection. The nodes are connected with each other in this fashion. And there is one storage is there, so these interconnected nodes are connected with the storage. This is the secondary storage, which is some terabyte is there, 56 terabyte in this supercomputer right now. And one is the data service is there. They have the libraries and all these meta data survey connectivity and other things we will take care about this. So this is the entire pictorial diagram of a supercomputer for solving your problem, a complex problem, not a simple problem. This machine already we have seen that, but yes, the pictorial diagram if we that how they are connected with each other. So one thing is very interesting that the firewall is here. So whenever you have the input, say for example, if you use the supercomputer, you type the login password, and then after you are doing processing or put the data that is via firewall. So outside users are connected with the supercomputer via the firewall. Then processing nodes comes into the picture. So these are the processing node. As we already see that this machine, they have the 3 type of processing nodes. One is the compute node, another one is the high memory nodes, and third one is the GPU nodes. Compute node for computing the problem, solve the problem, but their processing power is not as good as the GPU, as well as their storage is also not as good as the high memory nodes. So here, but the compute node takes less space, compute node cost is also less as compared to GPU. So here we have 192 compute nodes. Then high memory nodes, they have the huge memory. So whatever your data site, you are not worried about that. You can put entire data inside the nodes, not the secondary memory or master storage or secondary storage like this one. So otherwise what's happened that if you use these type of nodes, whenever you need a data, you need to fetch the data from primary storage or archive. So when you try to fetch the data, it takes delay and all other things comes into the picture. So, but if your data is itself inside that one, then you are not worried about all these things. GPU node is for the processing purpose, that whatever the data is there, whatever the processing is there, you can use the GPU node directly in that case. Now we come to the second layer. The second layer is the communication layer sort of thing. So here we have the communication between the service node and storage and between the processing nodes like this one. And they have the, that means these are the communication nodes are there in that case. Here interesting, one important thing is that the connectivity. You have seen that the 4 type of the color cables are there here. So each color cable, they have the different meaning. So say for example, the green color is the secondary connection, their capacity is the 1 gigabyte per second. That means their communication power is up to that one level. So you have seen that they are connected with each other. So one node to the another node, if you want to move, if you want to move the data from one node to another node, you can use these secondary connections. Or this, the second type of the cable is, this is the orange type cable is the 10G capacity. That means this is so fast, but of course, whenever you say the so fast, then definitely that means per unit time how much data they can communicate, and whatever how much data they can communicate, that is the different thing. So say for example, one cable is very fast, but they can communicate only the limited data. Other one is the capacity is speed is slow, but capacity is high. So we can't say every time the speed is very fast, then they definitely can transmit huge data at the same time. So such type of connections are from one section to the another section to the third one section, not within a one section. So green color connection is within a one section, but this yellow color connection is from one to the second to the third connection. That is the way. So this is the 10 GB speed is there. IP-MI cable we already seen that, which is quite fast, quite costly, and the connection with all these things together in that case. Fourth one is the infrared is there. That is especially for storage purpose. So storage is connected with this one, and they fetch the data and they store the data. So this is the way that how these nodes are connected with each other, and each connection they have their own property. We can't say that this connection is best in all the cases. So some connection they are high cost but high speed. Some connection they are the high speed but limited data transmission. Some are that is the high data transmission, high cost. So that means everyone they have the different properties in this case for the connection. So overall objective is that whenever you want to fetch the data from one section to the another section, you can do easily in that case. Achha, this picture is clear as compared to last one that we have seen in that time. So this is a quite clear picture in this case. So here we have seen that processing power, we already seen the 837 teraflop of the supercomputer. Okay, so and there are 192 CPU nodes are there, 20 high memory nodes are there, 11 GPU nodes are there. Here each node they have the 2 cores are there, then 22 are NVIDIA cards are there, V10, V100 PCIs. Total memory is 54.3 terabytes. When we merge all together, then we figure out this one. Interconnection, we already seen that the 10G, 1G Ethernet network connection is there because of cables. We already seen the cables, what type of the cables are there. Primary storage is 750 terabytes with 25 Gbps per second write through capacity. So primary storage is so fast, so you can easily read data from the primary storage. Now there are 3 type of the nodes in more detail is that we already seen that the CPU is 192, this cores and other things. So this is the description of the node that we can use in that case. I just go through that. That is the interesting thing is the login node and processing computing node. There are 2 different type of the nodes are there. This we just skip it here. Login node. So there are 3-4 login nodes are there. Login node is used only for the login of the user. Whenever the user they have the data, they go to the login page and then log in the machine and fetch the data or read the data from the login nodes. So login node is only work as a gateway between the firewall or between the system and in that person. So this is the difference between log. So whenever you use the machine, you need to remember that the login node is only for the login purpose, not for processing purpose. Okay, so if you try to run or if you try to process the data on login node, then the problem is that you are not able to utilize the machine. Login node is only for login, but the main capacity is at the compute node. So you are not using the machine and you feel that, oh, this machine is quite slow. Slow is there because of you are processing or you are doing the login node, not the machine. And if you want to make the speed up or want to use the fully speed, then definitely you need to compute on the compute node. Another problem when you run your program or simple Python script, machine learning script on login node, it might be possible you are not feeling slow down because of your script is very small and like this one. But what's happened that if you are running your script on the login node, other people are not able to log in at the same time. Why? Because your node is busy for computing the task. So login node is only for login purpose, not for computing purpose. Once you log in, you run your script for login script. Script assign the nodes, whatever the free nodes are there. Then you need to move in your given space and run the script in that given space so that they can successfully utilize the free nodes or assigned nodes. Otherwise, what's happened that if you run the login nodes, other people's you are computing your task on the login node, and other people's if they want to enter inside the machine, they are not able to enter inside the machine. They are not able to successfully log in. Why? Because of you already utilize the fully resources, whatever the resources are available, and resources of the login node. So that's why we have 4 login nodes. So that is more than sufficient if people are effectively use this machine. Earlier, what our experience is that okay, some users they put their program on the login node and try to execute. They are also not happy. Why? Because of the speed is not good, and others are also not able to log in. They are also fail every time. Why? Because of the login nodes are busy for some other task. So we need to take care about that thing. Now, in that case of the supercomputer for solving the complex problem, for solving the large size of the problem, what architecture is their operating system? So one thing is that these machines are on Linux platform, not the Windows platform. Of course, they have the different versions of the Linux or operating system. In their kernels type different is there, but have the Linux system, and CentOS they are using 7. Recently they update, I think the 7.2, but CentOS is there, and the Linux operating system is there. So if you are familiar with the Linux, you are not worried about how to use and all other things. Otherwise, you need to run on the command mode. Console is there. UI UX is not very rich, so that means you need to use the Linux or the command for running the program or for executing your program, whatever the program is there on the machine. In the operating system, of course, as you are familiar with the operating system, last one layer, and after that hardware comes into the picture. User is at this point, an operating system is here. So operating system, they also have a in that case, they also have the drivers, they control the hardware. So say, for example, if you take an example of a driver, what is the driver? Driver is, say, for example, if you have the camera is there. So drivers required, camera driver is required. If you have the printer driver is required, like this one. So they also have their own drivers, but this supercomputer, they use the Linux. So whatever the Linux default drivers are there, almost all the drivers are working here. So we are not worried about that type of the drivers challenges and other things. And operating system also take care about the networking devices, OFET and other things. After that, operating system, drivers and other things, file system comes into the picture, middleware application and management. So that is the file system is there, Slum scheduler is there, or they are coming in picture because of to control or manage the machine. Management is not only for this task management, but also users assign task or priority management. So say for example, right now we have the 11 GPUs, all GPUs are busy, and then 2 users, they try to access the GPUs. Both they submit their tasks, so we need to assign some priority of that task. Priority of the task, they take care about that, who else will the first, who else will the second, like this one. And all these things we can do with the help of Slum scheduler. So Slum designed by this solution. So Slum scheduler is used to schedule the task. Which one is the first, which one is the second, why that is the first, why that is the second, and all other things. So this is the job of the Slum scheduler in that case. So say for example, if you upload 2 machine learning programs, so which one is the first, which, because the resources are limited and that multiple users want to use GPUs and other things. If the machine is busy, then definitely we need to give some priority. So some scheduler is, such type of schedulers are required in that case. Now, if we talk about the account point of view, who else can access, who else can manage, how to manage, all other things. So there are 4 type of the users are there in the machine. One is the super users, which is the root user. Okay. And usually the root user has the root password, only one person they know the root password, and I think so right now all these root password are key generated, that is very complex password is there. So that is not a manually put a password as a root password because of that. There are two reasons. One is that is sufficiently strong is required, that a long root password is required, and memory person is not able to recall or remember. So that's why they need to write a function or the program and generate the password with the help of this. So one thing is that need a huge complex password because of this is the root. Entire machine power is there, so they can see, they can modify, they can delete, they can tamper of the others users data or the program. The second reason is that if you forget the root password, then it is very tough to retrieve and other things. So the recall or remember of the root password is also a challenge. So we can't use a long complex password because of the remember or recall is the problem. So this is the root password or root user. Second is the regular account. So regular account means a normal user account. So if you create an account, it goes in this category. In this category, you are limited. That means administrative power is not there. You can't see, you can't modify, you can't check the others users priority, properties, data, and other things. That is the account regular users. System account is to create the system account during the, so system account, say for example, if we have one system engineer is there, they have one account, and this account has the power to create the accounts or create the data for the others users. So if you want to access the machine, you send a request, we need to create an account. So all these things will be done by the system account. Service account is the last one, and they are creating whenever a service is installed on there. So say for example, if you want to install the Anaconda for machine learning, so Anaconda will install with the help of service account, not the system account. System account is for account management. Whatever the users systems are there, that management we can do with the help of system account. Service account is for managing the services, installation of the services, and all other. So this is all about the supercomputer. Now I think so you all are familiar with the entire supercomputer in terms of hardware, in terms of software, in terms of libraries and other things. Whatever the demand is there, you all are familiar with that one. Now we come to this machine learning, or how we can run the machine learning on the supercomputer. If you talk about the machine learning, then numbers of platforms are there, and IDs are there. IDs means you can directly use UI UX of that one, and backend they of course run the Pythons and other things. The backend, all they are the same because of the libraries. So Anacondas or Minicondas are the software distributor they widely use for data sciences to simplify the package management. So in that case, we are not worried about installation of all independent libraries, how to dependency are there, dependency connection and all other things. They will take care about this. That the Anaconda platform, they will take care about that. They automatically install or pre-install packets in your system of 1500 plus packets. If you directly install the libraries, then definitely it takes huge time, and integration is also. But Anaconda, they will take care about all these. Yeah, please.
Yes, sir.
Yes.
Whether the supercomputer is remotely accessible or physical accessible is mandatory.
No, supercomputer is remotely only accessible. Physical computer accessible is not possible.
Remote accessible is not possible.
No, only remote accessible is possible. You can remotely access the supercomputer. Physical accessible is not possible because
Okay.
it's not available. You have the login password.
So from anywhere we can directly store the content and expect us do some simulation over there.
Yes, so very first remotely, if you are somewhere else anywhere in India, you can send a request for user ID, create an account.
Okay.
So very first, you need to fill a form, create an account. Once you have the account, you have a user ID password. You can put that user ID password, and then you can access.
Okay. Thank you.
So now we come to the after the supercomputer, we want to run, of course, why we see the supercomputer only to run the machine learning programs and other things. So Anaconda or mini condas are the platform. Numbers of other platforms are there, but these are the interesting. And supercomputer, we already install all these type of the packets in this because of the students are using. So if you use the Anaconda, they already have the 1500 plus packages, NumPy, Python, or Pandas, or MATLAB, and all other things are automatically comes into the picture. Miniconda is another similar to the Anaconda, but they have the limited packets which are very essential for running. Not required to all the installation because all the installation takes time. And if you have the space, yes, please.
Yes, sir. Sir, whether it is recommended to use Google Colab platform or Anaconda directly installation, because Google Colab also support all the packages of Anaconda.
Anaconda is a platform, so it depends on you whether you want to use or you want to directly use the Python script for writing the program. And Google Colab is also a platform for running or execute your machine learning program. So you can directly run the Python program, not is requirement, but if you have the Anaconda type platform, then that is easy. That you can.
So it is faster in Anaconda.
Sorry?
It is faster to execute the program in Anaconda than in comparison to Google Colab platform.
No, they see. Google Colab is in between you and the server. Okay.
Yes, sir.
Server, what platform they are using, we don't know. Maybe possible indirectly they use Anaconda inside that one. You just paste you just write your script and press the button of the execution. Once on that your system to the server, then we don't know about server directly use the Python or server use the Anaconda at their platform. So that is their backend. So maybe possible your program goes to the server and the server call to the Anaconda, they copy paste your program on the Anaconda editor can Anaconda give the result and transmit the result to you. So we can see only the UI UX, whatever the Google Colabs they provide, but backend what type of IDs they are using, whether they are using or they directly use the Python, we don't know about that things. Another point is that usually what's happened that if you have the server, then you are not required to Anaconda. You can install all these 1500 libraries and everything. Why? Because whenever you put some intermediator between, anyhow, Anaconda also call the Python libraries and other things. So if you put some more in between, then your speed goes down. So first you write the program on Anaconda call the Python, then Python do and see the results and other things. So why we do all these things and the delay is there only because of the comfort, only because of the easiness. But if you can directly write the Python program and run it, then definitely that is required less resources as compared to the whatever the resources are required by the Anaconda and other things. Only that we need to manage the libraries, dependencies, and all other things. So then it is a little bit complex. So that means Google Colab, that is the platform where you can run the program, where you can type the program, where you can see the program. But we don't know about how they execute, what background they are using, or maybe possible they are using some different IDs. That is there. So in a supercomputer, if you want to run the program, you can run the program. You can install the Anaconda. If you are a very new person, then definitely you need to use the such type of IDs. Don't directly try to run. And this is the way that how to install the Anacondas. So in the supercomputer, when you create an account, you will get some space. I think 50 GB or 100 GB space is there. This is your space. And when you log out, when you log in once again, the space is there. Whatever libraries you have installed, configure, whatever data is there, that is as it is there. So when you get the space, that means some sort of VMs, we can say if we are doing in a different language, then some private space is there where you can install these packets, where you can put the data and all other things. So whenever you create an account, your account is there, then very first you can install the mini Anacondas and other things. Only one time, not every time. So one time you another thing is that one There are two types of the spaces there on the machine. That is, one is the common for all. So we already install numbers of packets. So this indicates that the libraries that we already there. And supercomputer, they already have all these libraries are pre-installed. So in that case, you are not required to install in your private space. So if any one library that is not available here and you want to install, then you can install in your private space, so that because why we have not installed all the libraries in our public space, because of slow down the machine unnecessary. Only one user is there out of 1,000 users. So whenever they want, they can use their own space, and we already provide the space in that case. So assume that you have the machine, you have the user ID, you have the password. So how you can install the program? So say for example, you want to install the Python program. So you need to check first that whether Python version is there, in which version you have write your program. So you check the Python 3.7 is there. They say that well, that means the list is there, and you can check the list whatever the programs are there, whatever the libraries are there. Next thing, you need to check that how many number of nodes are required, how many. So this is the way that how to write the script. So you need to write that, okay, I need a two normal node, two GPU nodes are required. My job name, my file name is this one, my output file is this one. If I want to transfer the result for someone else, this one. If I want to execute like this one. So these are the script that where you can write the script and how write the script. So this is an example of the script. So whenever you want to run the program, machine learning program, you need to write the script like this one. So here I write that, okay, I need a 16 nodes, and I think per core is 40 is required, and maximum duration of run is, I assume that it takes 6 minutes or 50 seconds, 6 hours 50 seconds and 6 hours 50 minutes and 20 seconds like this one. And the job, whatever the job name is there, file name is that is this one, whatever the error file is name is this one. So when they run the program, when they generate the file name is like this one. So very easily you can check that, okay, sometimes what's happened that we write that, okay, I need a 16 nodes, and we also write the node number 31 to 46. So it is not a good way. If these nodes are not available, then you can't run the script. They are waiting till 31 to 46 are available or not. But sometimes when we already check that, okay, these nodes are free and these nodes are the new one node and good node. Say for example, I'm using the machine since last 5-7 years. I know that which node moves faster, which node moves slower or faster. Why? Because of this is the new node replaced in 2023 because of any reason. So I know the number of that node, and that node is the new node. Definitely that is faster than the older one node. So what I will do, I know the name of the node, number of the node, and I will put that, okay, please allocate to that one node. So the machine automatically allocate that one node if the node is free. If not free, then you need to wait, because specific you write the name, number of the nodes. So once you run the program, this is your Python script for running for shell script is required. This is your SS file. Once you run the program, you have automatically these 2-3 files, because of you already write the file name. Okay, my error file is this one. My output file, result file is this one. This is my data set. This is my main file Python, and this is my script where I call these Python files and other things. So this is the way that how we can run the program on supercomputer. And this is the parallel processing that we already tell that supercomputer automatically converts. They have the capability that convert the sequential to the parallel. So here we can see that there are two types of parallelism is there. One is the model parallel, and other one is the data parallel. In the data parallel, we can divide into data into the sub data. So 1% data is we execute in this node, 1% data we execute in the other node. Model parallel, that means we can divide the model into the sub part. That means one deep learning model is very big size. We can divide into 4, and we can 3 part and case the 3 GPUs, 4 GPUs, GPU 0, 1, 2, 3, and run the program parallelly on 4 GPUs. And these are the libraries they use this one. So whatever your deep learning programs, say for example, you have the 20 layer CNN, you just put it there and call this library. They automatically convert into the parallel, divide the program into sub-program and execute like this one. And this is the internal code that so if suppose you have the ResNet 50, it's a very big model is there. So you can divide using this one libraries, and they automatically solve the problem. These are some results. So these result indicates that how parallel is there. So what is the advantage of parallel processing? So if I'm using only one GPU, I need 14 minutes. If I'm using 2 GPUs, I need only 11 minutes like this one. So it indicates that, okay, you can fast around 20-25 times if you have that 2 GPU node as compared to 1 GPU node. So parallel is always good, but parallel good up to a certain level in that case. Now quickly we see that about the edge devices. So up to now we talk about the supercomputer, machine learning or supercomputer, but edge devices are low cost. They can also solve the problem up to a certain level in a very effective manner. This is an example that you have the digital meter is there, the readings are there. This is one small edge device, small size of the device is there, one camera is there. They can capture the image and they can process all these data and they can okay, we can take that. We can do one thing. We can take a break here and we resume once again after 3:35, and a small portion is remaining. So we stop it here and we start once again at 3:35, and then we can finish this remaining topic at that time. Meanwhile, if anyone has any problem or any query, they can discuss with me. Thank you. So once again we start. So from edge to supercomputer, so we already seen about the supercomputer, how to process the information and what information we need to process. We have already seen in that case. Now we see about the edge devices, something about the edge devices, and after that I will share one file where some assignment is there, a small size of very small assignment, basics are there. Just go through that one and then try to solve that one. And if you have any query regarding to this, definitely you can mail me regarding to that assignment. So they will cover that whether you find out some interesting thing or not, or in that assignment you can also figure out some more challenging problems. So I will attach the file after this 15-20 minutes, then you can continue, and if you have any problem you can mail me. So we can see that the remaining slides. So here we already seen the supercomputer. So this is the supercomputer. Other one is of course the normal edge devices. And this is the example of how to use the edge devices with machine learning and in IoT. So assume that there is one distributor is there, where some readings are there. And the objective is that we need to make some device which they can capture this reading and process the data and transfer the data to the end user to generate the result and to see the result. That is our entire end-to-end story is there. So you need to capture some information, image, and do some processing, use the machine learning sort of thing on this data. Then after you need to use the communication protocol to communicate this information to the and but the one question comes into the picture, that why IoT comes into the picture and why IoT is so hot topic right now. Earlier people are not talking much about the IoT, but recently most of the people they talk about the IoT. So what's happened in the recent years? So one reason is of course the cost reduced in hardware. So right now the solution is low cost. Previous the cost is very high, and so it is very tough to purchase or process or use that cost hardware. Right now the cost is less, so person can easily go in the market and purchase the device and use that one. Earlier the cost is high and availability is less in the market, the devices are not available, then what we can do in that case. The second is that the connectivity advancement. So if connectivity protocols comes into the picture, new protocol, then definitely we can easily transfer the data and other things. So that is the second reason that why it is so easy. So availability of the connectivity or communication technology, we can say. So the data can communicate with each other effectively in a low cost, and people can use that one. Third one is the cloud computing and the edge computing. So the cloud is also very low cost, and the communication between edge device to the cloud is also available. So that is the another reason that why people are using such solutions. Fourth one is the interoperability standards. So that means Bluetooth can communicate with Wi-Fi, Wi-Fi can communicate with Bluetooth. Okay. So earlier that type of process are not there, so it was very tough to solve the problem because of if how to transfer the information or how to communicate the information from one platform to the another platform in that time. So right now that means it's an easy way, so that's where we can use that way. Regulatory support is also there. Earlier spectrum and other things problems are there. Now it's because of the availability of solutions and the computers and other things. So because of that reason, this type of solutions comes in. Consumer demand is also there. Previously, people are not purchased much devices. Right now, they are ready to purchase. Say, for example, if right now if we have the car, then they're ready to purchase the camera, desk camera, proximity sensors, and other things. And environmental monitoring and other things are also come. Say, for example, weather conditions and other things. Security, privacy improvement is the important. So earlier the security was not good. So people are worried about when they share their information. Right now, if machine learning demands the data, you can very easily send the data because of the you assume that your data is very secure in that case. Now, what issues are possible, but along with that advantage, some issues are still there. We can't say that everything solved or everything working smoothly. So, say for example, data overload. So, people store data or transfer data as much as possible, but even that is not required. The second is the data storage and management. So of course you can collect the data. Data collection is not a problem, but how you can process the data. So management and storage is the problem, where we can store, how to fetch the data. So say for example, Google Drive, we can put all the data, but think about the Google Drive, that how they manage the data storage and redundancy of the data one drive to another drive, and who else will pay all these management and other things. Data quality and accuracy, of course, when you have the huge data, then of course some data are read and some data are not correct. So that crowdsourcing data is there because the data generated with the help of some person or the cloud. So definitely some noise are there. That is, we can't say that the data is 100% correct. Network congestion is the not a problem, but yes, that is the challenge sort of thing. So sometimes what's happened that you have the huge data and use the Bluetooth or low bandwidth Wi-Fi. So in that case, data congestion comes into the picture because network are different. Sometimes they use the Wi-Fi, then Bluetooth, then Wi-Fi like this one, then 5G like this. So because of the combination of the network congestion comes into the picture. Or finally, the energy consumption is of course the problem always there. And as in the last picture, since we already seen, so that's why I skip this slide. So edge devices, whatever the low end devices, they have this type of machine learning, classification, linear and regression type sort of things. If we use this type of machine learning technique that we have seen in the last lecture, then deep learning comes into the picture. But what is the problem? One is, of course, if you use the machine learning, say for example, linear regression, handcrafted features are required. So need a one knowledgeable person. They can extract the features from this one. So that is the challenge problem. So a normal person, they are not able to use that one. So we need a one person. They have good knowledge about the feature extraction and other things. So that is the first challenge in the normal machine learning, whatever these type of machine learning techniques are there. The second problem is the scalability. So handcrafted features are for a large scale devices, that means where the devices are huge devices are there, heterogeneity is there. It is a challenging task. Not directly we can use that one. And data validity is whether the data is correct or not, and how we can play with the data in the handcrafted feature is this one challenge. And generalization is the final challenge, that whatever you are proposing a solution is suitable for the other devices is the in machine learning. So the solution comes from the deep neural network. So DNN solve these type of challenges. Whatever they propose the model, you are not required to extract the feature. They automatically generate the feature, whatever the features are required. And eliminate the need for the manual calculations. So you are not required manually calculate features and other things in that case. So performance improvement is very high if you use the deep learning techniques in place of normal machine learning techniques. These are some example of the deep neural network, CNN, that is the fully connected layer, and RNN. These are the example of this deep neural network that we can use the IoT. But when you use this IoT device, these solutions, deep neural network in IoT, we also face some challenges. Of course, one earlier that machine learning has the challenge, that's where the deep learning comes into the picture. Now deep learning has the challenge here. So one is of course the huge resource demand. So say for example, if you have the very big size of the CNN RNN architecture, definitely you need the GPUs, not the CPU. Even if you use the GPU, CPU, then it takes huge time in that case. So the resource requirement is high if you focus on such type of solutions, deep neural network based solutions in that case. And benefit of deep neural network is very high. So the solution is that you can use the compressed DNN. Compressed DNN means you can reduce the size of the DNN. Sometime we will take separate this topic. So this is the compressed DNN where you can reduce the size of the DNN. That means you can reduce the number of layers, you can reduce the number of columns like this one. So it is possible in compressed DNN where the size of the DNN is a little bit less as compared to original or the main model of the DNN. Benefit of the compressed DNN is you are required the limited storage because your size is very small. You are required less computation requirement because of you are not required as that level of operations at that case. And you can finish the training early because of you have the limited data and small size of the data in that case. So all these are the advantages in that case. And processing also, that means you are not required to transfer your data to the outside world because your data model is very small, so you can easily solve the problem in your system. So you are not required to transfer. So that means you can say that this is the in processing. That means you can process the data in you. So very first, machine learning comes into the picture. The challenge is that they are not able to solve the problem. Then deep neural network comes into the picture. The challenge, DNN is the resource constraint. Then compressed DNN comes into the picture. And compressed DNN solve all these type of problems. This is the survey of the compressed DNN technique. So today I'm not able to cover these things. So, but yes, various techniques are there. One paper is already published in this. You can go to my homepage and find out that paper, how to convert a normal deep neural network into a compressed neural network. So various phases are possible in the compressed neural network. That network tuning, that is numbers of ways are there. You can reduce the number of bits. You can reduce the number of layers. All these type of compressed techniques are there in the market. So you can use any one of these compressed techniques. So say for example, you can reduce the channel numbers because of, you can reduce or increase the window size, whatever the window size is given in your case. So this is the way that how we can use the compressed deep neural network in their cases. So this is the filter tuning. You can reduce the number of filters. So of course, when you reduce the filters, you can reduce the properties, but at the same time, you can improve the computational complexity in that case because you are required the less computational power in that case. These are also the another techniques of the filter tuning. So all these are the techniques of the filter tuning. So we are not focused on all the technique, but what's happened that whenever you are required, you need to just go through and find out which technique is suitable for your application. We can't say that always all the techniques are suitable for deep neural network on these things. These are some approaches that are proposed by some different researchers for compressed techniques. So all these are the compressed techniques. So how we can reduce the size of the model. It depends on the demand, it depends on the processing. So this is my last slide today. So we have, that means in this talk, we have covered about the supercomputer, and in terms of virtual tool, we see even a small video clip of the supercomputer. We also cover the different component of the supercomputer. We covered that how to use the supercomputer, how to write the script, how to write the machine learning program on supercomputer. Then after we have seen that, okay, how to use these edge devices for solving the problem. And since this edge device has the limited processing power, so you have the two options. Either you can go to the lightweight machine learning technique, but in the lightweight machine learning techniques, the challenge is that you are not able to find out the desired accuracy. So you need to focus on the deep neural network. But in the deep neural network case, problem is required the huge resources. So some compressed techniques are there. You can use the compressed technique. So you can convert a bigger size complex deep neural network into the lightweight deep neural network, and then you can burn that lightweight deep neural network in that devices. So you find out your result, whatever your result is there, whatever your desired result is there. So this is all about from my side in today's talk. And if you have any point, any suggestion, please discuss with me. Any point is there or any suggestion you want to discuss? Okay, good. So you have no point then. So I have some couple of points that I have noted down on one slide. So what you need to do, I will share this PDF file, one PDF file, just wait. This one. So these are some sort of, not the assignment, but some questions type are there. So my suggestion is that please try to address all these points, write some programs, some sort of things. And if you successfully write, then well and good. You are not required even submit to someone else. But if you have any point, have any doubt that what is the answer is possible in that case, so you can mail me, I will reply back accordingly. So here, what I try to summarize, I try to summarize the required, some sort of the machine learning point, some sort of the supercomputer points where we can use the supercomputer or HPC, what is the HPC. So with the help of these FAQs or some question answers are there, so that you can brush up your concept in that domain. But definitely there is no meaning for these things. So only that you need to brush up. And if you have any still any question or doubt in that, then you can mail me. So I will reply back accordingly. So hopefully that that means on Saturday we have taken a long talk of 2 sessions, and today we also take this is a long talk. So both together you find out some interesting facts about the machine learning and where we use the machine learning, what type of machine learnings are possible, and which system we can use the machine learning. So I hope so you enjoy these sessions, and so today we stop it here. So if anyone has any points or doubt, they can discuss. So anyone want to say anything else? So TLC की तरफ से कोई है क्या अभी ऑनलाइन? IIT BHU में TLC की तरफ से कोई है अभी? Okay, good है. मैं यूँ करूँगा कि I will do one thing. I will share this file, PDF file, whatever these points are there. The TLC cell will share with you. Right? So just check that anyone is there or not.
Yes, sir, one is there.
But they are not there, I think. So anyway, I will mail them and inform them. So from participant side, any point you want to discuss? TLC जितन जी हो गया है. Okay, fine. TLC told me that they will share this PDF file to you. So please, my suggestion is that don't spend 1 hour here and there. So try to read, at least read this, and if you find any interesting point, definitely you can communicate with me and we will discuss. So that is, we stop it here.
Previous page. Hello.
Yeah,
previous page थोड़ा सा दिखाइए. वो question वाला 1 to 5.
हाँ मैं अभी भेज रहा हूँ, अभी मेल कर रहा हूँ इस क्वेश्चन वाले को, है ना. इस कंप्लीट इसमें शुरू में कुछ पाइथन्स के हैं नॉर्मल है, देन आफ्टर दिस इज सुपर कंप्यूटर से रिलेटेड है और AI ML वगैरह एज कंप्यूटिंग से रिलेटेड है. यूजुअली यही क्वेश्चन हम लोग मोस्ट ऑफ केसेस में है ना यहाँ पर डिस्कस करते हैं, तो वही पॉइंट इसके अंदर एंटर करते हैं. मेरे पास एक सब्जेक्ट है, द वन सब्जेक्ट इलेक्टिव सब्जेक्ट ubiquitous computing. So usually we ask these questions in mid-sem and sem papers, so they are similar to that one. तो इसको थोड़ा सा एक बार देखें आप और ट्राई करें इसको आंसर देने का या अपने लेवल. So all the best for your program, and if anyone want to visit IIT BHU in the future, definitely they can visit the supercomputer that I am suggesting. That definitely you are welcome to visit the supercomputer. चलिए, thank you very much.